Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0101, refers to a MAF Sensor Circuit Range performance problem specific to the Honda CR-V model year range from 2011 to 2016. The mass airflow sensor is essential for measuring the amount of air entering the engine, which is critical for determining the correct fuel-to-air mixture for combustion. When this DTC is triggered, it may indicate an issue with the performance of the MAF sensor or the overall air intake system. This code may appear with the Onboard Diagnostics 2, OBD2, and can affect engine performance, fuel efficiency, and emissions. Prior to troubleshooting, it's important to gather all relevant data, such as freeze frame data and any associated diagnostic pending codes. If other related DTCs are present, those should be addressed before focusing on P0101, as they may impact the MAF sensor's function. The components affected when DTC P0101 is triggered primarily include the MAF sensor, PCV hose, intake air duct, air cleaner, and the purge line. The MAF sensor is located in the intake manifold and is responsible for calculating the mass of air entering the engine. The PCV hose connects the engine's crankcase to the intake manifold, ensuring proper ventilation and emissions control. The intake air duct directs filtered air from the air cleaner to the engine, and it must be intact to allow appropriate airflow. The air cleaner stores and filters air before it enters the engine, while the purge line allows for the vapor recovery from the fuel tank to the intake manifold. Any damage or poor connection in these components can cause incorrect readings or performance issues, which in turn may trigger the DTC. Possible causes for the P0101 DTC primarily stem from poor connections or damaged components within the intake air system. Poor connections can create resistance or interruptions in signal transmission, leading to erroneous readings from the MAF sensor. Damaged hoses, such as the PCV hose or the intake air duct, can result in improper airflow, directly impacting the sensor's readings. A dirty air cleaner restricts airflow, which may also confuse the MAF sensor, causing it to underperform. Malfunctions in the MAF sensor itself or associated components like the intake air temperature IAT sensor can lead to incorrect data being sent to the powertrain control module PCM, resulting in the DTC being triggered. The symptoms associated with DTC P0101 can vary, but commonly include a rough engine idle, which may cause instability when the vehicle is at a stop. Poor acceleration can occur due to an improper air-fuel mixture, leading to significant performance degradation while attempting to speed up. Increased fuel consumption might be evident, reflecting inefficiencies in the combustion process caused by incorrect sensor readings. An engine misfire may manifest in severe cases where the balance of fuel and air is significantly disrupted. The illumination of the check engine light is a common warning, alerting the driver to potential issues requiring attention. The first troubleshooting step for addressing DTC P0101 involves conducting a comprehensive parts condition check. It's essential to inspect for poor connections or damage to vital components such as the PCV hose, intake air duct, air cleaner, and purge line. A damaged hose or a poor connection can severely restrict airflow, which may cause the MAF sensor to read inappropriately. Make sure to check for any signs of cracks, tears, or loose fittings that would compromise the air intake system's integrity. If all parts are found to be in good condition, proceed to the next step to visually check the intake air duct, as it may still be a potential source of the issue. In the second troubleshooting step, you will perform a visual inspection of the intake air duct. It is crucial to establish whether the duct is damaged or loose at its connections to the air cleaner or elsewhere. A loose or improperly connected air duct can lead to unfiltered air entering the engine, producing inaccurate readings from the MAF sensor. If you discover issues with the air duct, such as disconnections or physical damage, these must be repaired or replaced. Once you have ensured that the air duct is secured in place and in good condition, you can then move forward to the next step of the troubleshooting process, which entails checking the air cleaner element. For the third troubleshooting step, focus on the air cleaner element to check for cleanliness. A dirty air cleaner element restricts airflow and does not allow sufficient air to reach the engine, which can adversely affect the performance of the MAF sensor. If the air cleaner is seen to be clogged with dirt, dust, or other debris, it will likely need to be replaced to restore proper airflow. Cleaning may sometimes be an option, but typically, replacement is a more reliable, long-term solution. After replacing the air cleaner, make sure to follow up with a repair verification to confirm that the issue has been resolved. Step 4 involves conducting a signal check of the MAF sensor without the engine running. Begin by turning the ignition switch to the lock position, and then switch it back to the on position, ensuring the engine is off. With an appropriate diagnostic tool, such as the Honda Diagnostic System, HDS, examine the readings for the MAF sensor against established threshold values. The expected output should be approximately 0.2 grams per second, GS. If the readings fall within the expected threshold, it indicates that the MAF sensor is functioning correctly at this point. However, if the readings are inconsistent or not as per specifications, the next logical step is to replace the MAF sensor or IAT sensor. In the fifth troubleshooting step, you will need to start the engine and assess the MAF sensor's performance during varying engine speeds. Specifically, increase the engine speed between 2,000 revolutions per minute, RPM, and 3,000 RPM, while monitoring the MAF sensor through the HDS display. It is essential that you observe whether the reading changes appropriately with the increase in engine speed, as it should directly correspond to increased airflow. If the values do not fluctuate as expected, it signifies a potential failure in the MAF or IAT sensor, necessitating their replacement. Upon validating a mismatch, the next step is to proceed with the necessary repairs. For the sixth step, maintain the engine speed at 3,000 RPM without a load, allowing the radiator fan to activate, and then shift to idle. It's crucial at this point to test drive the vehicle for several minutes, monitoring performance metrics, particularly those parameters recorded in the freeze data, such as engine speed, vehicle speed, and values from the manifold absolute pressure, MAP, and throttle position, TP, sensors. After completing the drive, you will check the onboard diagnostic status via the HDS to see if DTC P0101 still exists. If it indicates failed, the MAF or IAT sensor likely needs replacing. If it shows passed, this implies the system is functioning correctly at that moment. Upon completing repairs, it's crucial to perform a final verification to ensure that the issue has been resolved. Begin by turning the ignition switch back to the on position and utilize the HDS to reset the powertrain control module, PCM. This step will clear any stored DTCs and allow the system to refresh. Following the reset, perform an idle learn procedure to recalibrate the system based on the new sensor readings. Test drive the vehicle once more while monitoring various parameters like engine speed and vehicle speed to ensure everything is functioning normally. Finally, keep an eye on the OBD status, which should indicate passed. If any additional DTCs appear, further troubleshooting of those codes will be necessary. To prevent future occurrences of DTC P0101, regular preventive maintenance is highly recommended. Start by routinely inspecting the air filter. It's vital to maintain airflow and optimize engine performance. A clean air filter promotes optimal function of the MAF sensor and overall vehicle efficiency. Additionally, routinely check hoses and connections for wear or damage, since proper airflow and pressure are critical for the MAF sensor's accuracy. Any issues in this area can lead to problems. Furthermore, consider periodic cleaning of the MAF sensor itself with special cleaning products specifically designed for that purpose to ensure it operates within the expected range. In conclusion, understanding the function and importance of the MAF sensor in the Honda CR-V is critical for maintaining vehicle performance. The P0101 DTC signifies potential issues within the air intake system, demanding careful attention and systematic troubleshooting. Ensure each step, starting from component checks to signal evaluations, is followed diligently to accurately diagnose and resolve the issue. Implementing regular preventive maintenance can help mitigate the risk of future DTCs, especially those pertaining to the MAF sensor. By taking proactive measures and adhering to proper procedures, drivers can ensure their Honda CR-V maintains optimal operation and fuel efficiency. Please like and subscribe to the channel. See you next time.